Surprise! So in this video we will solve this beautiful integral, and the answer is also awesome when you talk to. And exponential integral of g is defined as integral from g to infinity of e to the power minus t by t dt, or from 1 to infinity e to the power minus gt by t dt. You can derive second one from the first one by a u substitution. Now let's begin the problem. So basically we have integral from 0 to infinity e to the power g, and there are two e of g's, yeah. 1 to infinity of e to the power minus gt by t dt. Let another be 1 to infinity of e to the power minus gy by y dy, and there's dz as well. Now let's compile them and let's rearrange them as well. 0 to infinity. Now, uh, okay, so e to the power minus g or t plus y minus 1 by t times y dg dt dy. Now these ty's are actually constant for g world, so I can write 1 by y over here, 1 by t over here, 0 to infinity. And now we need to integrate this thing. Now let us suppose that t plus y is greater than 1. So, yeah, so that this thing over here is positive. Yeah. And if we suppose that now we will be able to integrate this function, but let me do it in the next step. Dg dt dy. Okay, so 1 to infinity of 1 by y, 1 to infinity of 1 by t, and this is e to the power minus g t plus y minus 1 by minus of t plus y minus 1 from 0 to infinity dt dy. Okay, 1 to infinity 1 by y, 1 to infinity 1 by t. Now this is 0 and then minus minus plus 1 by t plus y minus 1 dt dy. Okay, so now from 1 to infinity 1 by y, and 1 to infinity 1 by t or t plus y minus 1 dt dy. Now we can use partial fractions for this. Yeah, 1 to infinity 1 by y and 1 to infinity. We can write this as basically y is constant for this integration. Yeah, so t plus y minus 1 minus t we can write, and also now introduce 1 by y minus 1 over here. Yeah, by t times t plus y minus 1 dt dy. So 1 to infinity 1 by y times y minus 1. Now this is 1 to infinity of 1 by t minus 1 by t plus y minus 1 and dt dy. Yeah, now from 1 to infinity of 1 by y times y minus 1, this is just ln t by t plus y minus 1 from 1 to infinity. Yeah, and then dy. So now 1 to infinity 1 by y times y minus 1. Now at infinity this is ln 1 by 1, so 0, minus at 1 this is ln of 1 by 1 plus y minus 1, so y dy. So this is 1 to infinity. Now this is just ln y by y times y minus 1 dy. Now if you want to make it go to 0 to infinity or 0 to 1, we can do it anyway. We can either take it to 0 to 1 form or 0 to infinity form. Both of them will work. For 0 to infinity, we can let's say t as ln y. Yeah, and if we do that, this will go from 0 to infinity, and it will be t by, now 1 by y dy will be dt, and we will have e to the power y minus 1. Now you might know a standard integral, that integral from 0 to infinity of t to the power s minus 1 by e to the power t minus 1 dt. This actually equals to gamma of s zeta of s. If we use that, this is gamma of 2 zeta of 2. So that's why this is 1 times pi square by 6, and that is the answer. Yeah, pi square zeta of 2 is the answer. Yeah. Now if we try to change this to the other form, 0 to 1 also, it will be pretty easy in both the ways. 1 to infinity of ln y by y times y minus 1 dy. Now if you want to change it to 0 to 1, you can take t is equals to 1 by y. That will give us 1 to 0 minus ln of y by, sorry, not y, t now, t, and then now this will be 1 minus t, or t square minus 1 by t square dt. Yeah, and t square cancels out, minus minus cancel out, so this will be minus integral from 0 to 1 ln t by 1 minus t dt. Now I can use King's rule. Yeah, King's rule is basically integral from a to b of f of x dx. This is equals to integral from a to b of f of a plus b minus x dx. So if we use that, we get minus integral from 0 to 1 of ln of 1 minus t, and over here that will be just t dt. Now you might know that Li2 polylogarithm function, so dilogarithm function Li2 of x is basically minus integral from 0 to x of ln of 1 minus t by t dt. This is basically, that's why this is basically Li2 of 1. Yeah. Now there's also another property known as LAS of 1 is known as is actually cos zeta of s. So this is equal to zeta of 2. That's why this is pi square by 6. So basically, you can take the limits of integration to any standard form, and then the answer will simplify. That was the gist of the both of the ways. So the flow was to expand it to double integral and rearrange the terms, so that's so that the first one will simplify and use integration by parts, normal formula, and nothing, just some, now change the limits to a standard form, some like well-known forms, and use the standard formulas. Basically this can be derived using geometric series. Yeah, multiply by e to the power minus 1, and then we'll get geometric series. And this is also from the definition of Li2 function. Also we can expand this into our Taylor series and then get the answer. Yeah, you can take the Taylor series of ln1 minus t and then see that this holds. So that was it. Hope you enjoyed the video. Thanks for watching. Look forward to seeing you in the upcoming videos too.